Let's take a look at one of your lab problems from section 7.2. This is problem number 1. They want us to find the integral of 15 times cosine to the fifth of x dx, and we're going to evaluate that from 0 to pi over 2. Alright, so in order to integrate this, we want to change all but one power of cosine to sine. And so we're going to split this up into cosine x times cosine to the fourth x. Now cosine to the fourth x is the same as cosine squared x squared. And so if we can replace this cosine squared x with something with a sine, then that's going to be our key. And our basic identity is sine squared x plus cosine squared is equal to 1. So if we solve for cosine squared x, we're going to get 1 minus sine squared x. After doing so, we will see that this cosine squared x is actually equal to 1 minus sine squared x. And then we can FOIL out this expression, the 1 minus sine squared x squared. And so that's going to be 1, and then the middle term is going to be twice times the product of 1 and negative sine squared x. And then we have sine squared x squared, which is sine to the fourth x. And so our integrand is going to be cosine times that. So this is going to require us to put that same number. Now that we have that, we're going to distribute the cosine x. So cosine x times 1 is cosine x. And then cosine x times 2 sine squared cosine x, or I'm sorry, cosine x times 2 sine squared x is going to have 2 that. And then we have sine to the fourth x times cosine x, since that's the last term. Okay. Now we're going to note that each of these has a cosine x associated with it. Now the first one is just the integral of cosine x, but then the others will be a u substitution, as we'll see. And so this is our integral then. We have a 15 being multiplied, so those are constants that we can take out. The 2 that we had in the middle term will become 15 times 2, and then we have 15 here. So we're going to take it one by one. First, we're going to deal with this. So the derivative of not the derivative, but the integral of cosine, and remember the integral and derivatives are different. So the integral of cosine is going to be sine x positive. So we'll get the sine x going here. And sine x evaluated at pi over 2 is going to be equal to 1. So this is going to be 15 times 1 minus, and then the sine of 0 is 0. So that's just going to be 15 times 1, which is equal to 15. So we have 1 down, 2 to go. The other 2 will be u substitutions. If we're going to let u equal to sine x, just the sine x, so that the derivative is going to be cosine x dx. So just one sine would do. The derivative of sine x is cosine x, and so for limits of integration we should change that as well. When x is equal to pi over 2, our u value is going to be sine pi over 2, which is 1. And when x is equal to 0, our u value is going to be 0. So this is going to go from 0 to 1 instead of 0 to pi over 2. So now we integrate 0 to 1. So remember that u was equal to sine x. So this is actually u squared. And we're just integrating u squared. So that's u cubed over 3. And we integrate that from 0 to 1, so this is going to be a negative 30, that constant sitting out there. And then we have a 1/3 minus, and then we put 0 in there, we get 0. So 1/3 times 30, I think that's equal to 10, and the negative sign remains. So that's two integrals down. Our last one, we'll do the same thing. We'll let u equal to sine x again, and then we'll have a cosine x dx as the derivative. So that's the du that's going to get replaced. And so we're just going to integrate this. So this is going to be 15 times, the integral of this is u to the 5th over 5. And so we put 1 in there, so that'll just be 1/5. And then we put 0 in there, we get 0. So 15 divided by 5 is 3. Okay. And so let's see, well, let's collect all our information here. The first integral here was the cosine, and that we got a 15 out of that. And in our next integral, we got a negative 10. And then our next integral, we got a positive 3. So 15 minus 10 is 5 plus 3 is 8. So this whole thing should equal to 8. Okay, so that's it. That's our first problem.